All right, this video is about piecewise defined functions. And so piecewise, that's a funny word. It's the word piece and wise stuck together. Piece meaning pieces, like chunks of things, but we're referring to this in terms of functions. And so we definitely can have a scenario where we need multiple functions to describe that scenario. So we want to work with those functions, and so we're going to look at some examples to help you through that lesson. The first example is we have y equals, and there's always curly brackets when associated with these. We have negative x, and then we have x plus 6, and they have contentions with them. So they say if x is greater than negative 3, and this one says if x is less than or equal to negative 3. So what it's saying is that it looks like the one function if we have values of x that are bigger than negative 3, and then it looks like the other function if we have values that are less than 3 or equal to. So we want to graph this. It'll ask us to graph these. So let's go ahead and draw our Cartesian coordinate plane at the moment. Get ourselves prepared. And I might not have given ourselves enough room, so let's make this a little bit bigger. Okay. So what does this look like? Well, we need to have some sort of kind of table of values here, so we can really see where we're graphing. We need some points to graph. And so let's go ahead and do that. So our table of values is going to look like so. So we have x and y. And so let's look at the top one. So it looks like negative x if x is greater than negative 3. So we have to pick values greater than negative 3. Now, notice it's not equal to negative 3, so we need to also kind of include negative 3 just so we know where it starts. Because remember, it does include numbers that are not whole numbers. So it doesn't start at negative 2, it starts at negative 2.9999999. So we start with a negative 3 in there. And then we need bigger, so negative 2 and negative 1. And that's probably good enough for us. If we plug them into the function, remember this one is going to plug into this top function where it's associated. So if I have a negative 3, that's going to give me a positive 3. If I have a negative 2, that gives me a positive 2. And a negative 1 gives me a positive 1. Awesome. Now let's take a look at the other one. So this one says if it's less than or equal to negative 3. So we're going to have negative 3, but in this case, we're going to have numbers that are smaller. So negative 3, negative 4, and negative 5. And we're going to plug them into the other one where it's associated. So we have negative 3 plus 6 gives us 3. Negative 4 plus 6 gives us 2. Negative 5 plus 6 gives us 1. Okay, how do I graph this? Well, let's start with the one we just did. So we're going to plot negative 3, 3. And because this has an equal sign, it will have a closed circle there. Negative 4, 2, so right here. And negative 5, 1 here. And of course it keeps going on towards the negative x's. So this one looks something like this. Now, what does the other one look like? We have negative 3, 3. So notice it's in the same spot, but technically, because that one didn't have an equal sign, it would be an open circle for that one. We don't really need to put it there because it's covered by the other one. So that's totally fine, but I just want you to be aware that it would be an open circle. And then we have negative 2, 2. So that's here. And negative 1, 1 here, and it keeps going towards the positive x's. And so that's what this function would look like. So this is a piecewise function. Let's look at another example. There are things called a step function. A step function is something that is considered to be a piecewise function. And so when we look at what does that look like, how is that represented in a graph, let me show you. So we have our Cartesian coordinate plane. Always have to start with that. And so a step function, this would be one representation. They can be kind of different, just depending. But let's start with just an example of them. So now we can really see what it means, why it's called a step function. It looks like stairs. But this would be a piecewise function because we don't have one algebraic way to write as far as symbols go that would represent this entire graph. So each one of these would actually be a separate function. So we'd have several pieces of this puzzle to represent this graph. But that's what a step function looks like. All right, last example. This one's a word problem, so let me read it. The hourly wage increase each employee receives each year depends on the number of years of service. Every 3 years of service means an increase of 50 cents per hour. So every 3 years means they get 50 cents increase in pay. Okay, so employees that have been with the company for at least 3 years but less than 6 years can expect an increase of $1 per hour. Employees that have been with the company for at least 6 years but less than 9 years receive an increase of $1.50 per hour. And employees of at least 9 years but less than 12 years receive an increase of $2 per hour. So we want to write a function that represents this scenario. Okay, so a lot of words there, but let's go through it step by step. So if we have to write a function for this, we get to start with our curly brackets. And we start with the first one. So it says, every 3 years of service means an increase of 50 cents per hour. So employees that have been with the company for at least 3 years but less than 6 years expect a dollar. So every 3 years. So from 0 to 3 years, right? Means, I'm going to erase that just for a second, that they get 50 cents. So 0.5 so if, right, the same way we saw the other one, you've worked with them for up to 3 years. And the reason why we don't put an equal sign at the 3 is because the next step, because it says that somebody who has worked for the company at least 3 years, but less than 6, so almost 6, get $1. So they get $1 if they have worked with the company at least 3 years, but less than 6, so not quite 6. What is the next step? Employees that have been with the company for at least 6 years, but less than 9, receive $1.50. So 1.5 if they've been with the company 6 years to the day, but less than 9. And then last but not least, it says employees that have been there at least 9 years, but then less than 12 years receive $2 increase. So they get a $2 increase if they've been with the company 9 years to the day, but less than 12. Wow, what did we just write? Well, we wrote a piecewise function, but if I actually were to graph this, this would look like our step function that we saw, because it's not going to continuously go up. Between 0 and 3, it's just 50 cents regardless. Between 3 and 6, it's just $1 regardless. Okay. So after watching this video now, you need to give me a call so we can discuss this video and answer any questions that you have. And then you can use this information to help you through the lesson that follows. Have a great day.